This question is describing a situation that I've shown above. You see that the amplitude of the spring is 57 centimeters. We know the amplitude is what I've drawn here in red arrows. It's the distance from the equilibrium position to the furthest amplitude of the spring. The time it takes for one pulse is 0.75 seconds, and the speed is 2.3 meters per second. The first thing we're being asked for is the length of the pulse, and we know that the length of the pulse is equal to the speed multiplied by the time. So we can say that we have 2.3 meters per second multiplied by the time, which is 0.75 seconds. And we get that the length is 1.875 meters. For significant digits, we would say is 1.9 meters. And that's the length of the pulse, which would be the length of either a crest or a trough. What the next part of the question is saying is what's going to happen when the pulse hits the fixed end and reflects. So that means if we put right here a fixed end, this green wall, and the pulse reflects in the other direction. So because we have an ideal spring here, what's going to happen is the pulse is going to be inverted, but everything else is going to stay the same. So that means the amplitude would stay the same. We know our amplitude is 57. The length, which is 1.9, would stay the same. The speed, which is 2.3, would stay the same. But the pulse would reflect, which means that if we would say that the pulse is looking like this as it goes towards the wall, then it is going to go like this as it goes away from the wall. So that would be towards the wall, that would be away from the wall. So for this question, we have a frequency of 2 hertz, we have a speed of 5.4 meters per second, and it's asking for the wavelength. We're going to use the universal wave equation, which means we're going to use our speed is going to be equal to our frequency multiplied by our wavelength. If we arrange this for a wavelength, we are going to get our speed divided by our frequency, which means we are going to have 5.40 meters per second divided by our frequency, which is 2 hertz. For unit analysis, you can remember that a hertz is equal to 1 over seconds, which means that our seconds are going to cancel out. We are going to get that our wavelength is 2.7 meters. If I were to draw my wave right here, if I were to do that, you want to make sure that you remember that a wavelength is going to be the distance between two identical points. So that right there would be our wavelength.